The National Electrical Code requires that special devices known as ground fault circuit interrupters, or GFCIs, be installed in places like kitchens, bathrooms, crawl spaces, garages, or in outdoor areas where water is often present. Two common types of ground fault circuit interrupters are the circuit breaker type GFCI and the receptacle type GFCI. GFCIs are highly sensitive and are designed to trip when they sense conditions that would produce potential shock hazards known as ground faults. A ground fault occurs when electrical current fails to follow its intended path and is diverted or drawn away through another conductor. If a person were to accidentally touch a partially grounded device, the current could seek to return to ground by passing through them. This could result in a shock, burn, or electrocution. This leaking of current may be a result of faulty wiring or improper electrical connections. A GFCI's job in a home's wiring system is to monitor the flow of electricity through a circuit. It's frequently believed that GFCIs detect fault currents. The truth is that GFCIs detect what's known as differential current. When a GFCI receptacle senses even the smallest change in current from what is going out versus what is coming in, it trips. GFCIs can sense changes in current as low as 5/1000th of an amp and can shut off the power within a 40th of a second. In homes equipped with circuit breakers, a circuit breaker GFCI may be installed in the service panel to give protection to all devices on that circuit. Circuit breaker-style GFCIs serve a dual purpose. Not only will they protect against ground faults, but they will also trip when a short circuit or an overload occurs. Receptacle-style GFCIs fit into standard electrical boxes and protect you against ground faults whenever electrical devices are plugged into those outlets. Let's take a look at an example where we have a receptacle-style GFCI installed in the middle of a run. Whenever you put a GFCI in middle of run, you have the option of wiring this GFCI to provide single location protection for just this one receptacle, or you may wire this GFCI to provide multiple location protection for all other electrical outlets farther downstream on the same circuit. GFCIs are different from normal receptacles and must be wired in a special way. To understand this, let's take a look at the back of a typical receptacle-style GFCI. Notice that there is some important wording and descriptions that you must understand to wire GFCI receptacles properly. First, you'll see words indicating line and load, and other words indicating hot and white. These two screws are the set of line terminals. To these terminals, we will connect our line wires. We'll discuss this in a moment. These two screws are the set of load terminals. Also, each terminal set has both a hot side, indicated here by these brass terminal screws, and a white side, indicated here by these silver terminal screws. Lastly, this green screw is the receptacle's ground terminal. Now, let's see how to properly wire a receptacle-style GFCI in the middle of run as we've seen before. In our first scenario, we'll show you how to wire a GFCI so that it provides single location protection for all devices plugged into only this one receptacle. We will flip this GFCI over to give you a better view during this procedure. We begin by connecting the incoming line cable's hot wire, or the black wire from the power source, to the outgoing black wire which leads to other downstream devices. Then we use a pigtail to connect these black wires to the hot line brass terminal on the GFCI receptacle. Use a wire connector to secure the three wires. Next, connect the incoming and outgoing white neutral wires together. Again, use a pigtail to join these neutral wires to the white line silver terminal on the GFCI receptacle. Lastly, connect all your ground wires together. Again, use a pigtail to connect the green grounding screw on the GFCI receptacle to the other ground wires. If you're using a metal electrical box, add an additional pigtail to connect your ground wires to the grounding screw on the side of the box. Now, If current were flowing through this circuit, the electricity arriving at the receptacle will be free to continue down the line to power other devices, because here we have a constant connection. Now, if we go back to the front of the receptacle, we'll see that if a plug were inserted, the current could also pass through the GFCI receptacle, out to an appliance, and return again back to ground on the neutral wire. Since this example is only wired for single location protection, if a ground fault were to be detected at this receptacle, the GFCI would trip itself and all power to any devices plugged into this receptacle would cease. At the same time, all other devices downstream from this receptacle will be unaffected because the flow of current would continue. Now, another way to take full advantage of this GFCI would be to wire it to provide multi-location protection for other downstream receptacles. This is how you would do it. First, take the incoming black hot wire and connect it to the brass screw at the hot line terminal. Then take the outgoing black wire and attach it to the brass screw at the hot load terminal. Next, take the incoming neutral wire and connect it to the silver screw at the white line terminal. Then, connect the outgoing neutral wire to the silver screw at the white load terminal. Lastly, connect the ground wires and ground terminal on the receptacle together in the same fashion we showed you before. So now, we see that the incoming current arrives at the hot line terminal first, and then passes into this GFCI and out to other devices downstream. The current then returns along the neutral wires, and the GFCI functions just like a normal receptacle. Again, looking at the front, if a ground fault were ever to occur on a device plugged into any of these outlets, the change in current would be detected here. The GFCI would trip and immediately stop the flow of current to all downstream devices on this circuit. In one final example, if you wish to install a GFCI at an end-of-run location, the way you would wire this situation is different. Follow these procedures. In this situation, you will use only the GFCI's line terminals. Connect the incoming hot wire to the brass screw at the hot line terminal, and then connect the outgoing neutral wire to the silver white line terminal. Leave the load terminals empty. If you are using a plastic electrical box, connect the ground wire directly to the grounding terminal screw on the receptacle. If you're using a metal electrical box, pigtail the cable's ground wire to both the ground terminal on the receptacle and the electrical box, as we've seen before. And now, since this GFCI is at the end of a run, it will provide you single location protection for all devices plugged into its outlets. Because GFCIs are sensitive to current change, they're most effective when wired to protect a single location. The more downstream locations any one GFCI protects, the more susceptible it is to phantom or nuisance tripping. This is a case where a GFCI will misinterpret a tiny, normal, or harmless fluctuation in current as a potential shock hazard and will shut off the power to the circuit. If you ever wish to replace a conventional receptacle with a receptacle-style GFCI, follow these instructions. First, shut off the power at the breaker that controls that circuit. Use a circuit tester to verify there is no current present by inserting the probes into both the top and bottom sets of outlets. Remove the faceplate. Loosen the mounting screws and gently pull the receptacle from the box. You should test again that there is no current by touching the circuit tester probes to both the top and the bottom set of terminal screws. If you find there's only one cable entering the electrical box with a black, neutral, and ground wire, this is an end-of-run receptacle. So wire the new GFCI as an end-of-run GFCI receptacle using the method we just showed you. If there are two cables entering an electrical box, treat this as a middle-of-run receptacle. What we must determine is which of these cables is the line cable or the cable bringing in the hot wire from the power source. To do this with our example, Disconnect the black wires or black wire pigtails from the receptacle's brass terminals. Separate these black wires and position their ends suitably so that there is no chance they can make contact with anything. To find out which of these two wires is the incoming hot wire, temporarily turn back on the power at the circuit breaker. Then with our circuit tester, we can test to see which black wire is hot by touching the tester's probes between each black wire and the neutral or left slot on an outlet. When the circuit tester glows, you've found your hot wire. Turn off the power again at the breaker and identify the line wire or the incoming hot wire you just discovered by clearly marking it. Now, disconnect the neutral and ground wires still attached to the receptacle. Locate the neutral wire that shares the same cable with the hot wire and label it. These are your line wires. So now that you have the incoming and outgoing cables clearly identified, determine whether you want to wire your new GFCI for single location or multiple location protection, and follow the wiring procedures we showed you before. Once you've wired your new GFCI to meet your needs, reset the breaker to turn back on the power to the circuit. Follow the manufacturer's instructions to test your new GFCI to be sure it's working properly. On the front of this receptacle, you'll see two test-related buttons. One button is labeled Test, and the other is labeled Reset. Press this Reset button first before testing. If your new GFCI is functioning properly, this will reset it to normal working order. Now, a very easy way to perform a test on your new GFCI is to plug in an appliance or other electrical device like this small lamp into one of the GFCI's outlets. Now, if your GFCI is working correctly, pressing the test button will simulate what the receptacle would do in a ground fault condition. This will turn off the power to anything plugged into this outlet. Or if you wired this GFCI for multiple location protection, it will also turn off the power to all other devices found downstream from these outlets. Pressing the reset button again should restore current flow to the circuit or to any device plugged into the outlet. You may also diagnose the integrity of a receptacle-style GFCI by using a plug-in GFCI tester. These instruments plug directly into GFCI outlets and analyze the GFCI's connections and wiring condition. If the tester detects any wiring problems, its indicator lights will display the reason for the wiring fault. A chart of potential wiring problems can be found on the face of the tester. These devices are similar to normal receptacle testers, except they have a trip button that accomplishes the same thing as a GFCI receptacle's built-in test button. Depressing this button will cause a properly functioning GFCI receptacle to trip. Where you have multi-location GFCI protection, you can also check a GFCI by plugging in the tester to a downstream outlet. And when you press the trip button, the upstream GFCI should trip. As a general rule, never assume a GFCI device is operating correctly until you properly test it.
So further to ground fault circuit interrupter receptacles, I have a great video that I'd like you to check out. We'll provide a link to. And I demonstrate the use of Mr. Wiener, how a GFI actually works, and real-life demonstration of how it trips when you have a fault to ground. Also on GFI receptacles, you'll notice on the back of them, they have those two holes that would look like push-in connections on a regular receptacle, but really they're not. What they are is you strip the wire to the gauge, the strip gauge provided on the back of the receptacle. Then you make sure the terminal is loose. You push that wire into those holes, and then you tighten the screw down, and that puts pressure on that wire itself in a straight-in fashion. Now, some inspectors may not allow you to use both those holes as a feed-through. I personally see no issues with that because you might even get a better connection because now you've got a wire on either side of that pressure plate that you're tightening with that screw terminal, and with wire on both sides you're going to get even pressure on the wires, and again, quality of work. If you do a proper connection, tighten that screw properly, you're going to have a good connection. But you do want to check with your inspector to see if they'll allow you to use those as a feed-through. The other method, of course, is to pigtail and use one hot wire And you can use the terminal by wrapping the wire around the terminal screw, or those push-in, or not push-in connections, but those straight-in connections, and then tightening the screw down.